Welcome to Matlab video series, Chapter 2, Creating Arrays. An array is a list of numbers arranged in rows and or columns. The simplest array is a row vector or column vector. In science and engineering, one-dimensional arrays frequently represent vectors and two-dimensional arrays often represent matrices. Here we have a row vector, RA equal 2i plus 3j plus 5k. To represent RA in Matlab, we can put the elements between square brackets separated with commas, or you can separate the elements with space. Second, we have a column vector. The same RA equal 2i plus 3j plus 5k is represented as a column vector with a semicolon separating the elements. There are two methods in which we can create vectors with constant spacing. First is using the colon notation. For example, x equal 1, 3, 5, 7, 9, 11. Here, each element is at a constant spacing of 2. So, we can represent it in Matlab as in square bracket 1 colon the increment or the decrement. In this case, the increment is 2. So just write 2, then again a colon, and the last element 11. Second example is where your increment is 1. So 1, 2, 3, 4, 5. Each element is at an increment of 1. So you don't have to write the increment here. You just write the first element, which is 1, and the last element 5, and a colon in between. So by default, the increment is 1. The second method is using the linspace command. Here you have to specify the first term, the last term, and the number of terms. So we'll consider the same example. So x equals linspace, the first element is 1, last element is 11, and the total number of elements is 6. Now, if we do not specify the number of elements, then by default we will have 100 elements. For example, n equal linspace 1, 40 gives 100 elements by default at constant spacing between 1 and 40. Creating matrices, which are two-dimensional arrays. What is a matrix used for? You can store information like in a table, and they play important roles in linear algebra and in science and engineering to describe many physical quantities. Here is a square matrix, which means we have equal number of rows and columns. The matrix B in this case has 4 rows and 6 columns. So the dimension of this matrix is 4 by 6. How to enter a matrix in Matlab? You have to always start with a square bracket, type the elements in every row wise, and to go from one row to the other, you use a semicolon. So we have an example here, and example number 2 is where we use the enter key. We can also use variables which are predefined within the matrices, or we can use built-in functions as well, as in this case. CV is 6, V is 3, H is -2, and we are also using a trig function here. These are some special commands. First we have the zeros command. Zeros 3, 4 creates a matrix with 3 rows and 4 columns. Ones 3, 2, we have 3 rows and 2 columns, and IF4 gives an identity matrix of order 4. Remember, an identity matrix is always a square matrix. The smallest identity matrix is of order 2. All variables in Matlab are considered as arrays. So a scalar is an array with one element, a vector is an array with one row or one column of elements, a matrix is an array with elements in rows and columns. Now, once a variable exists as a scalar, vector, or a matrix, it can be changed to any other size or type or variable. The transpose operator. We have a vector here, s equal 2, 5, 8. It is a row vector. To make it into a column, you can use the transpose operator. That is the apostrophe. So S transpose makes the S into a column vector stored in R. You can use the transpose operator on a matrix as well. So we have a 3 by 4 matrix here. We use the transpose operator, so the rows become columns and the columns become rows. Array addressing. The address of an element in a vector is its position in the row or column. So for a vector named VE, VE of k refers to the element in position k. The first position is 1. We have a row vector here. So when we say A equal V of 3, it refers to the element in the third position, which is 8. If we want to replace the element in the fifth position, which is 1, 2, 3, 4, 5, we have a positive 2 here. We want to replace it with a negative 2. We address it as V of 5 equal negative 2. So the new V has the positive 2 replaced with a negative 2. We can also use addressing to do some mathematical expressions, as in this example here. Addressing a matrix. The address of an element in a matrix is its position, defined by the row number and the column number where it is located. For a matrix assigned to a variable m, m of m, n refers to the element in row m and column n. We have a matrix here, capital M. B equal m of 3, 4 refers to the element in the third row and the fourth column, which is 1. If you want to replace the element in the second row and third column, which is second row, third column, we have a 5. We want to replace it with a negative 6. We say m of 2, 3 equal negative 6. So it assigns a new value to the second row, third column. The matrix indices begin from 1. The matrix indices must be positive integer. Using a colon in addressing arrays, VA of colon refers to all the elements of the vector VA. VA of m colon n refers to element from mth position to the nth position. And here are some examples to demonstrate that. For a matrix, A of colon, n refers to elements in all the rows of column n of matrix A. So we have a matrix A here, and when we say A of colon, 2 refers to the elements in all the rows of column 2 of matrix A, which is 8, 6, 6. A of n, colon refers to elements in all the columns of row n of a matrix A. So A of 3, colon refers to elements in the third row, and it covers all the columns. So it is 5, 6, 8, and 12. A of all, which is colon, m colon n refers to the elements in all the rows between columns m and n of matrix A. So D equal A colon, 2, colon 4 refers to the elements in all the rows between columns 2 and 4. A of m to n, p to q. We have an example here. A is defined. F equal A of 1 colon 3, 1 colon 3 refers to all the elements from first to the third column rows and first to the third columns. So always we have rows first and then columns. Let's do an example. A matrix is given. Now you have to define the matrix A in Matlab and use it to construct a column vector B using the elements in the third column. So let's open the Matlab window. A equal, let's define the matrix. For the first row, you have a constant spacing of 2. So you can use the colon notation. Let's go to the next row. We have zeros command here. So zeros of 1 row and 3 columns. Leave a space. And you have -2, -1, -4. Go to the next row. We have a pattern. So 3 times ones of 3 rows and 3 columns. And right next to it you have the identity matrix, which is I of 3. Now let's save this file. Run it. There's an error, so here we have to correct that as close all. Okay. Now let's do part A of this question. Make a comment here. Part A. Define or construct a column vector B. So it's going to be B equal, using elements in the third column. So third column, which means all the rows, third column, and you want it to be a column vector. So that's it. Let's run that, and here we have a column vector. Next is define a row vector C with elements of fourth column followed by elements of the sixth column. So elements of the fourth column, which means all rows of the fourth column. But remember, we want a row vector, so let's put a transpose operator, put a space, A of all rows in the sixth column, again a transpose, and we have to put this within square brackets. So we have a row vector as the question tells you. Next one, define a matrix E from the elements in rows 2 through 4 and all the columns in matrix A. We're going to define a matrix using elements in rows 2 through 4. So 2 colon 4 and all the columns. So we have the colon here. That's it. You can try the remaining 2 parts later on. Solutions are here on this slide. How to delete elements from a vector. We have a vector here and we want to delete the element in the 6th position. So we address it as G of 6 and you assign it to an empty matrix. Now if you want to delete a set of elements, you define it using addressing. So G of 4 to 6. So from the 4th position to the 6th position, all the elements will be deleted. That is, here we have in position 4, 8. 5 we have 9, and in 6 we have 4. So all these 3 elements will be deleted and you have a new vector G. Deleting elements from a matrix, we follow the same idea. You address whatever you want to delete. So for example, you want to delete elements from all the rows from the 2nd and 4th column. So you say colon, comma, in square brackets 2, 4 equal empty. So we have a new matrix M which is smaller in size. Concatenation of matrices, which means joining two vectors or joining two matrices together. You have x and y and z. These three are vectors. If you put x and y together, you have a new row vector, 1, 2, 4, 5. If you put x semicolon y, the 1 and the 2 will come in the first row, and then the y, which is 4 and 5, will go to the next row. But if you try xy semicolon z, you will get the error saying vertical cat dimensions are not consistent. These are the built-in functions which you should know. Length of A returns the number of elements in vector A. Size of A returns a row vector m, n, where m and n are the size m by n of the array A. So you have size of A here is 2, 5. That means we have 2 rows and 5 columns. Reshape, it's a very important command which is used for reshaping any matrix. But what is the rule here? It creates a m by n matrix from the elements of matrix A. The elements are taken column after column. Matrix B must have m times n elements. So if you want to reshape A, which has 2 rows and 3 columns, you want to reshape it to 3 rows and 2 columns, it is possible using the reshape command. So reshape A, 3, 2. You can also reshape it to 6 rows and 1 column. So reshape A, 6, 1. Another possibility is reshape A, 1, 6. Next command is the diagonal command, diagonal of V, where V is a vector. It creates a square matrix with the elements of V along the diagonal. We can also use it to extract the diagonal elements from a matrix. So A is a matrix, and when you say diag of A, you get the diagonal elements 1, 7, and 11. Next we'll discuss about strings. A string is an array of characters. It is created by typing the characters within single quotes. Strings can include letters, digits, other symbols, and spaces. When a string is being typed in, the color of the text on the screen changes to maroon when the first single quote is typed. When the single quote at the end is typed, the color of the string changes to purple. What are the uses of strings in Matlab? It is used in output commands to display text messages, in formatting commands of plots, as input arguments for functions. Here is an example. B equal, in single quotes, my name is Rose. So the output comes as a string. When you address B of 4, we have N in position 4. So the empty space is also counted as a position. B of 4 to 10, so we have the following output: name, space, S. This is another example. We have a set of letters, special character, digit. How to use the character function? It creates an array with rows having same number of characters from an input of rows not all of the same length. So the length of the row equal length of the longest row by adding spaces at the end of short lines. Rows are entered as strings separated by commas. This is an example. You say a variable name equal char, char character command, and then the different strings. So roster equal character, name as a string, UIN, net ID, and the major. So this will be displayed like this. How to do a character to string conversion and vice versa. It is using integer to string or number to string commands. It converts an integer or a real number to the corresponding character string. So integer to string of 2 plus 3 is the string 5. One way to label a plot is title, then you have a case number, and you say integer to string of that particular number. For matrix or vector inputs, integer to string returns a string matrix. So integer to string of I of 3 returns a string matrix. String to number, it converts string to a number. So str to num, so string to number of 2, 4, 6, 8 in single quotes, you have the numbers here 2, 4, 6 and 8. You can also separate them with commas, or you can put them in square brackets. The variable defined as a number or string, how do you identify that? So when x is equal to 23, you see x displayed as 23. The characters below x equal are indented. So x can be used in mathematical expressions. Whereas y equal 23 in quotes, the characters below y equal are not indented. So y cannot be used in mathematical expression. Let's work on some questions from Gillette, Chapter 2. This is question number 29 from your textbook. You have to create a matrix A. So here we'll use the colon notation 1 to 6. For the next row, we can use the linspace command. First element is 7, last element is 12, and total we have 6 elements. And the last row 13 to 18. Let's run that and check if it's okay. Now part A, you have to create a 6-element row vector named HA that contains elements of the first row of A. So A of first row, all columns. Let's check if it's okay. So that is the 6-element row vector. Part B, create a 3-element row vector named HB that contains the elements of the 6th column of A. So A of 6th column means it covers all the rows. So you put a colon and then 6. Let's run to see what we get here. So here we have a column vector, but what we need is a row vector. So we have to put a transpose and run that again. So we have a row vector here. Let's move on to question number 2, which is question 31 in your textbook. Create the vector C, which is quite long, but we can identify that there is a constant spacing of 1.2. So instead of counting the number of elements, we could use the colon notation. Start with the first element 0.7, increment 1.2, and the last element 17.5. Use Matlab's built-in reshape function and the transpose operation to create the following matrix D from the vector C. So let's just run this to see how many elements are there. So we have a total of 15 elements. We can reshape it to get D. Reshape. Let's try 3. So C, comma 3, 5, because 3 multiplied with 5 will also give us 15. Let's run that, and it doesn't look like the matrix we need. So let's try 5, 3. It's almost there, but we need a transpose operation, as the question tells us. So now we have the desired matrix. Now let's do part A only for this question. Create a 9-element column vector UA, so UA equals, that contains the elements of the first, third and fourth columns of D. So we have all the rows of the first column, then next to it all the rows of the third column, and all the rows of the fourth column. Now individually this would be column, this would be a column, and this would also be a column. And we need a 9-element column vector, so one below the other. So we need to put a semicolon and close all this, or enclose them in square brackets. Let's run this, and we have a 9-element column vector. Question 33 or 32, which would be question 3 here. Create the following matrix E. So question 3, E equals, we can use the zeros command. We have 1 row and 4 columns. Next to it we have 2 as a common factor, and you can use the ones command with again 1 row and 3 columns. We go to the next row with a semicolon, and here we have a decrement of 0.1. So we put a negative sign there, and the last element would be 0.1. Next row we have 2, 4, 6, 8, 10, 12, 14. So 2, increment of 2 till 14. And the last row we have a decrement, so 22, negative 3, and 4. So that is our matrix E. We can check whether that is the matrix. Okay, that looks fine. Let's do part A. Create a 2 by 5 matrix F from the second and fourth rows and the third through seventh columns. So F equal E of, we are being selective, we just need the second and fourth, so 2, 4 in square brackets, and the elements from the third through seventh, so 3 till 7. Here it should be a colon. That's why the error came. Unbalanced, unexpected parenthesis in line number 30. Now let's run that. So it looks fine now. And the last part, which is part B. Create a 4 by 3 matrix G from all rows and third through fifth columns. So G equal E of all rows and the third through fifth columns. Let's run that. And that's it. Last question, question number 4. Create a 2 by 2 matrix A in which all the elements are 1. So ones of 2, 2. So that's a 2 by 2 matrix. Then reassign A to itself several times such that A will become this. So let's do it part by part. We have 0, 0, 0, 0 here. That would be A of first row or first 2 rows and the first 2 columns equals zeros of 2, 2. No, it should actually be the third and the fourth columns. So let's see the new matrix A. Okay. So now we can go to the bottom part, A of third and fourth rows and first 2 columns equals zeros of 2, 2. Okay, but we want one more change there. So A of again third and fourth rows and third and fourth columns, we'll change it to ones the second chunk is just like what we have here. So we can say the new A is A and another A concatenated together. Okay, so that's all.